Now see the solution of test 1. First question is find the inverse of A by elementary column transformation. So first you have to find the value of determinant of A. If that determinant value not equals to 0, then that matrix is invertible. So we find A inverse. So we have to write A inverse into A equals to I. Now substitute the value of A. Here given matrix is of order 3 by 3. So we replace the matrix identity by 3 by 3 order matrix. So first we required the elements in first row as 1 0 0. So we use these two elementary column transformation. Here we required 0, so we write C2 minus 3 times C1 we required at second column, so we write C2 changes to C2 minus 3 times C1, and in place of these 3 we required 0, so we write for this C3 minus 3 times C1 we required these changes in third column, so we write C3 changes to C3 minus 3 times C1. Now after applying this transformation you get the values in left hand matrix and right hand matrix. You can check the value. Then we required, after applying this column transformation, we required 1 in second row. So this one we have to reduce to 0. This is already 0 and this is 1. So at the place of A21, here value is 1, so we have to reduce this value. So we use the elementary column transformation as C1 changes to C1 minus C2. So third transformation you use, C1 changes to C1 minus C2. So after using this elementary column transformation you will get the matrix in the form. So then we get the value in first column as 1 0 0, second row as 0 1 0. Then we come to the last row and we reduce last row from right to left in the form 1 0 0. So here we get 1, here we get 0. Now in place of A31, that means in place of this one we required 0, so we use C1 changes to C1 minus C3. So using this elementary transformation you will get the matrix in post multiple to A inverse as identity matrix and right hand matrix. So when we multiply by identity matrix to any matrix we get the inverse, means that matrix. So A inverse, if you calculate, that must be equals to this value. Now see second question is find the adjoint of matrix A. Matrix is of order 3 by 3. So first we write A11, that means element of this matrix at position A11 which is 2. So minor of 2 we find by eliminating first row first column, that is determinant of 1 2 1 2. So determinant of 1 2 1 2 is 0, so we write M11 as 0. Then we have to find the cofactor. We use the formula Aij equals to minus 1 raised to the power I plus j into Mij. So here I is 1, j is 1, so we write A11 equals to minus 1 raised to the power 1 plus 1 which is 2. M11 is 0, so we get here value 0, and we use the shortcut when we add the position, that means when we add the value of I and j, if that value sum is even number, then we do not change the sign of minor, that is the cofactor, and when sum is odd then we change the sign of minor, and that after changing the sign we get the cofactor from that minor. So similarly you can find the remaining minor and cofactors in this way. Now you have to check the cofactors are 0, -8, 4, -1, 3, -2, 1, -7, 2, and from this we have to write cofactor matrix. So first we write the cofactor matrix, and when we take its transpose, the transpose of cofactor matrix is nothing but its adjoint. Therefore we write adjoint of A equals to Aij its transpose. So we write here element in first row in first column. So elements in first row are 0, -8, 4. So we write this element in first column. Element of second row are -1, 3, -2. So we write second row element in second column, and this third row element 1, -7, 2 in third column. So in this way we can find the adjoint matrix of a given matrix. First we have to find the minor, then we have to find the cofactor, and from that cofactor we have to find the cofactor matrix. Then we have to take the transpose of cofactor matrix, and that obtain the adjoint of A. Now next question third. A equals to 2, -1, 1, -1, 2, -1, 1, -1, 2. Find A inverse by adjoint method. That means here we have to find again minor cofactor, then cofactor matrix, transpose of a matrix, and then by using the formula A inverse is equals to 1 by A into adjoint of A. So we have to find the directly cofactors as A11 equals to -1 raised to the power 1 plus 1, and this is minor of A11. So we get minor cofactors, or you can first find the minor, then find the cofactors, then find the cofactor matrix. You have to just check the cofactor that you calculate. First cofactor is 3, second is 1, third is -1, fourth is 1, fifth is 3, sixth is 1, seventh cofactor is -1, eighth cofactor is 1, and ninth cofactor is 3. So from that we write the adjoint of A. Now we have to find determinant of A, because we know the formula A inverse equals to 1 upon determinant of A into adjoint of A. So calculate the determinant of A, and we get determinant of A equals to 4. That means you calculate determinant. Now by using the formula for A inverse, so write A inverse equals to 1 upon determinant of A into adjoint of A. Now substitute the value A inverse equals to 1 by 4, and substitute the value of adjoint of A. So this is A inverse by using adjoint method. Question number 4. Find the inverse of A, and matrix A is of order 2 by 2. So first we find the determinant of A. We get -2, which is not equal to 0. That means inverse of this matrix exists. So we write A inverse into A equals to I, or A into A inverse equals to I. Here we can use only row transformation. So you can use here column transformation also. So you use first transformation as R2 changes to R2 minus 3 times R1. Second transformation -1 by 2 times R2, and third transformation R1 changes to R1 minus 2 times R2. So you get the value A inverse is equals to -2, 1, -3 by 2, -1 by 2. or when you take 1 by 2 common, in place of this minus 2 1, you will get minus 4 2 minus 3 minus 1 when you take 1 by 2 common. Now see question number 5th. If A is equals to element in first row are 1 2 minus 1 and element in second row are 3 minus 2 5, apply R1 interchange to R2 and then C1 changes to C1 plus 2 times C3 on A. That means first you have to interchange these two row. So we interchange here 3 minus 2 5, which is in second row we write in first row, and element in first row which is 1 2 minus 1 we write in second row. Then we have to apply C1 changes to C1 plus 2 times C3. That means we have to add element of first column with element of third column after multiplying by 2. So when we multiply by 2 to 5, we get 2 into 5 10, 10 plus 3 we get 13. So we write here 3 plus 2 into 5, 1 plus 2 into minus 1. So changes after changing you get A changes to 13 minus 2 5 minus 1 to minus 1. Now see question number 6. Find which of the following matrices are invertible. That means you have to just find the determinant. If that determinant equals to 0, then that matrix is invertible. So in first 2 1 4 2 you get 0. That means this matrix is singular, hence its inverse does not exist. That means A is not invertible. In second, when we find determinant of B, we get 1 which is not equal to 0. So B is non-singular. So B is invertible. That means you can find the inverse of matrix B. For matrix C, if we calculate the determinant, we get minus 12 which is not equal to 0. That means C is non-singular. Hence C is invertible. That means you can find the inverse of matrix C. Question number 7. Find the inverse of A by using elementary row transformation. So here we have to find the determinant of given matrix first. That we get 1 which is not equal to 0. That means this matrix is invertible. That means we can find the inverse of matrix A. Then you have to write A into A inverse equals to I. Then substitute the value of matrix A, identity matrix I. Then use first row elementary row transformation as R1 changes to R2. Then second transformation as R2 changes to R2 minus 3 times R1 and R3 changes to R3 minus 2 times R1. Then after applying this elementary transformation, you have to apply R2 changes to minus R2. That means we have to multiply by minus 1 two elements of second row. Then use R1 changes to R1 minus R2. Then you use R1 changes to R1 minus 2 times R3. So you will get A inverse as elements of first row 1 2 minus 2, elements of second row minus 1 3 0, and elements of third row as 0 minus 2 1. So in this way you can solve the given questions. If you have any problem, then you have to see the videos from chapter matrix from same YouTube channel for how to calculate the inverse, how to calculate the adjoint of a given matrix, also for finding minor and cofactors.